When it comes to smartphones, even back in the early days, I've gotten requests from many people saying that they don't want a phone that heats up. Now, there's a lot of issues with this one simple sentence and it opens up a can of worms. So in today's video, let us go through why your phone heats up and how we can mitigate this issue. This is going to be a long-ish video, so we'll have to separate it into a few different segments, so everything is timestamped below here. But I urge you to watch the entirety of this video from start to finish because everything is interconnected. Segment 1. We'll start off by talking about the chipset of a phone. As the name suggests, the chipset is literally a set of chips. It is a common misconception that people call chipsets as cores or CPU. Those are names inherited from the old days, but as technology advances, they've become SoCs, also known as System on a Chip. Now let's take the Snapdragon 888 for example. It's an SoC and we can look at the block diagram to learn what's within this one chipset. And we can see here that there are a bunch of different components integrated into a single chip, hence that's why it's called an SoC. As you can see here, the CPU is only a small part of the entire chipset. That Qualcomm Cryo 680 CPU is further broken down into smaller components into its individual cores themselves. Now, as you know, smartphones use ARM-based cores. That's why all of the chips are called ARM Cortex whatever cores. How all these cores are arranged, clocked and designed is commonly referred to as the CPU architecture. More on that later because it is very important. Now, up until now, what we talk about is only the designing part of the chip itself. ARM doesn't sell physical products, they sell the core's designs only. And then companies like Qualcomm buy this kind of design and then they will integrate it alongside with other components of their own to make a chipset. That is why we get the Snapdragon 888. Okay then, how do we make these physical chips to be used in phones? And now it's time for segment 2, manufacturing. Fabless chip designer companies like Qualcomm, Nvidia, AMD and even Huawei's Kirin will seek out some other fabrication companies like TSMC, GlobalFoundries, Samsung and many other more to manufacture them into physical products. One common misconception here is the process node, that whatever number NM technology that many companies like to use in their marketing. That whatever NM number purely means the gate length of an FET, also known as a field effect transistor. That gate length is the physical length between the source and drain channel of that transistor. And this number used to be very straightforward back in the days of 2D transistors. It's just a physical measurement of that distance and we're done. But ever since 3D transistors are introduced, for example FinFET during Intel's Ivy League days, that number has kind of lost its meaning because you can't really measure 3D transistors' gate length. One excellent article here is by Dr. Ian Cutress by AnandTech that highlights this particular issue when it comes to IBM's world's first 2nm chip. In short, different companies will measure this gate length differently. And having the smallest NM number doesn't automatically means the greatest performance or an even more efficient chip. It solely means that you can cram more transistors within a certain area of space. That performance and efficiency mostly stems from the chip's architecture, which we have talked about in segment 1 of this video. Now, segment 3, same chip, different performance. So now the chip is made and installed into a motherboard and made into a smartphone. Here are where things start to get a bit wild. Two different smartphones with the exact same specs can behave and perform very differently in the same game or benchmark. So why is that? There are actually two reasons for that. Reason number 1 is actually because of thermal design, aka thermodynamics design. Now, I'm not an expert when it comes to thermodynamics, but I avoid calling it cooler design because there are actually two types of coolers. Either we can go for active or passive coolers. Most phones use passive cooling, for example this ROG Phone 5 that has no fans and it only dissipates heat through thermal conduction and also convection throughout the surrounding air. That's about it. Passive coolers are just not enough when it comes to high performance devices. The heat produced versus the heat eliminated from the device is just not balanced. So that is why the temperature of your flagship smartphones will tend to be so high, and it also overheats constantly. We've seen many smartphone companies try to solve this issue by implementing some sort of specially designed liquid cooling, vapor chamber and all of those stuff, but for all I can tell you, they are mostly misleading. The term liquid cooling here is used in marketing, and yes, there is liquid in the heat pipe, but that's not what the real liquid cooling is supposed to be. Real liquid coolers have a fan, radiator, pump and coolant. And before I ramble on even further, I just want to point out that the reason why the Nubia Red Magic 6 can outperform the ROG Phone 5 is because the Red Magic 6 has a little fan inside. Personally, I don't think that's a good idea to put a fan in the phone because it cannot be serviced easily and thus the lint will definitely get in. Furthermore, having an opening to take in fresh air means no IP rating, and that fan will inevitably die at some point in time. And as a quick mention, the performance difference between a phone and a tablet with the same specs is huge because a tablet has a much larger surface area to dissipate the heat as compared to a phone. And the second reason why two phones with the same specs will perform differently is because of thermal throttling. Thermal throttling is also known as thermal limit in some cases. A chip generates heat as the clock speed goes up, and so to avoid the chip from getting overheating and damage itself, a thermal limit is set. How this works is rather simple. If a thermal sensor detects that the temperature is lower than the thermal limit, then the chip can operate at higher performance. But when that thermal limit is hit, then the performance will need to be lowered to prevent that overheating from happening. That is how thermal throttling essentially works. So I can think of some examples now. For example, the Galaxy S21 Ultra has a thermal limit of 46 degrees Celsius, and same goes to the newly announced Xiaomi 11T and 11T Pro. But this thermal limit can be changed via software update. Like the Poco F3 for example, when we reviewed it, it overheated like mad to the point where the screen dimming happened, and it's just really bad experience overall. So as far as I know, what Xiaomi or Poco did is to push out an update to update its thermal throttling limit, the thermal limit to 46 degrees Celsius. I personally think that implementing thermal throttling via software update is a touchy subject when it comes to Poco F3 especially. You see, the main appeal of the Poco F3 is the performance out of that Snapdragon 870 chipset. So when it overheats and thermal throttling is needed, that means you're essentially paying more for that chipset but for the performance that you cannot use due to thermal throttling. Yeah. Now, segment 4, how do we solve this issue? Honestly speaking, none that I can think of without relying on these companies to design and fabricate more efficient chips with no major issues. In the meantime, we can get ourselves some phone coolers. For example, the one that I encountered that is effective is the Black Shark Fun Cooler 2 Pro. It works on nearly every phones out there in the market right now, and it really does bring the temperature of your phone down by a lot. So, back to the question at the beginning of this video then. Can you actually get a phone that doesn't heat up? Not really that possible, because even entry-level phones like this, depends on what you're doing, it can still heat up, but not as bad as the ROG Phone series, because these are high-performance chips with proper, I wouldn't say proper ventilation, it's just proper heat conduction design to the point that it will heat up the entire phone. And yeah, you get the idea. This is like 50 something degrees easily. So conclusion, we've talked about many things regarding phone and heat, but these are some of the things that I have to leave out in this video because it's just way too long already. Like how the phone of the material will affect thermal transfer, how the weight of the phone can be a telltale sign of how the phone's thermal conductivity is gonna be, and also if a phone case will make or break your thermal performance. Even software and its optimization can have a heavy impact in terms of performance and temperature. We have not touched on those topics at all, so I'll just leave those for the next video. And yeah, do let us know if you want to see a follow-up with more in-depth, little minor explanation of all these subtopics. Long-time followers of this channel will also know that we dropped benchmarks in our phone reviews a long time ago, and that is because, number one, benchmarks don't represent real-world usage at all in terms of performance, and secondly, some smartphone manufacturers literally cheat in their benchmarks, and that is why we would rather just show you gaming performance videos instead. However, performance monitoring on smartphones is very difficult on Android phones, so we'll also leave that topic for another day. Yeah, this is all that we have to share with you today regarding phone and why it heats up, how you can mitigate it, but generally you can't really avoid it. So yeah, if you have any questions, do leave them down in the comment section below. If you want to learn more about all the expanded topics for the future, do let us know as well, because we do have to prepare for it. Yeah, and we'll see you guys in the next video.